All right, so now we're going to look at the sum of two cubes. So in the previous video, we looked at the difference of two cubes. Now we're going to look at the sum of two cubes. So in other words, it'll look like this. Your expression will look like a cubed plus b cubed. So your polynomial can be written like this. And it turns out that you can factor the sum of two cubes just like you did with the difference of two cubes. It will be a binomial times a trinomial. It'll be a binomial times a trinomial. And your binomial is a plus b. And your trinomial will be a squared minus. See how this is a plus? So your sign's going to see how this is a plus here as well? Your sign's going to be different here. So it'll be minus ab and then plus b squared. All right? Now, let's just multiply this out and make sure we get this. So just to verify that this formula gives us this back. All right, so remember what we did. So to multiply binomial times a trinomial, we take each term of the binomial and we multiply by the trinomial. So in other words, we'll have a times a squared minus ab plus b squared plus b times this trinomial, so plus b times a squared minus ab plus b squared. All right? So using distributive property, a times a squared is a cubed. A times a negative ab is a negative a squared b. A times a is a squared, so I get negative a squared b. Plus, and then a times a positive b squared is a positive a b squared. So when I distribute the a here, this is the trinomial I get. Over here, when I distribute the positive b, I get b times a squared is a squared b. B times a negative ab is a negative ab squared. And b times a positive b squared is a positive b cubed. Okay, combining like terms, I get a cubed. All right, and over here, this negative a squared b and this positive a squared b, so those two terms here, when I add them up, I get 0. Over here, a positive ab squared and a negative ab squared is 0 as well, the sum. The sum is 0. And all you're left with is plus b cubed, and that's what you wanted to come up with. So this is how you factor the sum of two cubes. Now, so I'm going to just go ahead and rewrite this over. So a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Now, I'm going to go ahead and remind you what the difference of two cubes look like in terms of factoring. So it's very similar to this. So remember, it's a binomial times your trinomial. So when I factored the sum of two cubes, remember this is a plus b, that's your binomial. Here, remember, that was a minus b. And then when you factored it, you got a squared for your trinomial, first term of your trinomial, except remember that if this is a minus b right here, then this will be a plus symbol. So it'll be plus ab and then plus b squared. So the only difference between these two formulas is the signs of the binomials and the signs of the second term of the trinomials. Everything else stayed the same. All right? Okay, so let's go ahead and factor this example. So this will be number 1. So let's suppose we had m cubed plus 27n cubed. M cubed plus 27n cubed. All right, so the GCF here is 1. GCF is 1. So now let's see if this is the sum of two cubes. Since the exponent's at 3, let's just see if it's the sum of two cubes. So let's see if I can fill in these parentheses. So this will be m right here, because m times itself 3 times is m cubed. Here, that's going to be a 3n, because 3n times itself 3 times is this. 3n times 3n times 3n is 27n cubed. Okay, so just like when we did the previous section, this previous lesson, this can be your f and this would be your L. So when I factor the sum of two cubes, my binomial will be f plus L, and my trinomial will be f squared minus FL plus L squared. All right? So think of this as your f and this is your L. Okay, so my binomial is f plus L, so I'm going to get m plus 3n, f plus L. So m plus 3n times, all right, now remember this says I take f, whatever f is, and I squared. I multiply by itself twice. So f here is m. So m times m is m squared. Then I got to say subtract f times L. F times L. Well, remember f times L here is f is m and L is 3n. So m times 3n is 3mn. So that goes here. And then here, that says I take L and I square it. So I take L and I multiply by itself 2 times. So L here is 3n. So that means 3n times 3n is 9n squared. So that goes here, plus 9n squared. And there's your answer. Okay, that's all you do. All right, now, before I go any further, remember in previous examples, when we got something in the answer and we said, well, can I go any further? In other words, can I factor this further? Well, m plus 3n, the GCF is 1, so you can't take out anything here. Here, this trinomial, don't waste your time and try and see if you can factor this two binomials. You cannot. No matter what you try, nothing works. So in this formula right here, when you use this formula, these trinomials, you cannot factor further. These trinomials in the formula are prime. So in other words, I cannot factor these any further. Okay? So don't waste your time doing that. It cannot be factored further. All right. So, but before going to the next one, let's just check this. Now remember on the test, you're not going to have time to check this, but let's just check one of them. So let's just check this one. So remember, when I multiply this out, I want to get this back. So hopefully we'll get this back. Okay? So remember, you take each term of the first factor. So the first factor is m plus 3, and so you take each term here and you multiply by the trinomial. So take each term of the binomial, multiply by each term of the trinomial. So in other words, we'll get m times this trinomial, m squared minus 3mn plus 9n squared plus 3n times this trinomial, m squared minus 3mn plus 9n squared. All right, and then so then we use a distributive property. I get m times m squared is m cubed. M times a negative 3mn is a negative 3m squared n. M times a positive 9n squared is a positive 9m n squared. Over here, so when I distribute the m, this is what I got. I just multiply every term by m, and this is what I ended up with. Over here, I'm going to distribute mn. So multiply every term in here by mn. So mn times m squared is 3m squared n. I just put the letters in alphabetical order. Minus 3m times a negative 3mn is, that's 3n, sorry. 3n times a negative 3mn is a negative 9mn squared, because n times n is n squared. And then a positive 3n times a positive 9n squared is a positive 27n cubed. And then combining like terms, I'm going to get m cubed. There's no other m cubes anywhere. So I get m cubed. Now over here, this is a negative 3m squared n. Here's another term, 3m squared n. So when I combine these like terms, a negative 3 and a positive 3, that's 0 when I add them up. Here, these right here are like terms, mn squared, mn squared. A positive 9 and a negative 9. When I add these up right here, I get 0 as well. And I'm left with plus 27 n cubed, which is what I wanted. So this right here is correct. All right, so let's look at number 2. All right, so number 2, let's suppose I want to factor 5k cubed plus 40. 5k cubed plus 40. All right, so again, look for the GCF. The GCF here is 5. GCF is 5. All right, so GCF is 5. Now, even if you didn't look for the GCF, let's suppose you went directly to seeing if this, as it looks, is the sum of 2 cubes. Well, obviously it's not, because there's no whole number times itself 3 times, that's 5. And there's no whole number times itself 3 times, that's 40. So you cannot go directly to this right here. So you have to use the GCF first. So if I factor out the GCF, and that's what you should always do, is factor out the GCF first. Factor out the GCF first, I get 5 times, and that's k cubed plus 8, because 5 times 8 is 40. So now I want to see if this binomial can be factored further. Well, you should notice that k cubed plus 8 is the sum of 2 cubes. That's the sum of 2 cubes. So the first parenthesis is k, and the second parenthesis is 2, because 2 times itself 3 times is 8. K times itself 3 times is k cubed. So there's your F, and there's your L. So now we factor this as F plus L. So remember, right here, F plus L. You're not going to see it, but so F plus L, so K plus 2 times, and this says I take F and I square it, so I take K and I multiply by itself twice, so that's K squared, minus, don't forget minus now, F times L, so I take F and L and I multiply them together, so K times 2 is 2K, and then I take L and I multiply by itself twice, so I take L and I square it, so L here is 2, 2 times 2 is 4, so that's plus 4. All right, so k cubed plus 8 is this. Now, don't make a mistake and write this as your final answer to the original problem, because in the original problem, remember, we took out the GCF, which is 5, so 5 has to be part of our answer. So we 5 times k plus 2 times k squared minus 2k plus 4. And so there's the answer here. Okay? All right, let's look at number 3. Suppose I had 8m cubed plus 64. 8m cubed plus 64. All right, so always look for GCF first. So GCF here is 8. GCF is 8. All right, so I can factor out an 8. So I'm going to get 8 times m cubed plus 8, because 8 times 8 is 64. So 8 times m cubed is 8m cubed. 8 times 8 is 64. Just like we did this one, just like we did this, you work it on the side. So we can do the same thing here. M cubed plus 8 is the sum of 2 cubes, because this is going to be m, and this will be a 2. And so here's your F, here's your L, and so just like this one, see they're very similar, except instead of K, we're going to use M. We're going to get M plus 2 times, I take M and I multiply by itself twice, so that's going to be the first term of the trinomial, so M squared, minus f times L. So remember, f is m, L is 2, so that's 2m, and then plus L squared. So that's 2 times 2, which is 4. So that is going to go here. So I'm going to get 8 times m plus 2 times m squared minus 2m plus 4. And remember, when you factor, see how the GCF here is 1? GCF is 1 now. So when you factor this, don't waste your time factoring this trinomial. You cannot. So if you think, well, isn't that m minus 2 times m minus 2? No, it's not. Because the outer and the inner, when added up, gives you negative 4m, and you wanted a negative 4m, and you wanted a negative 2m. All right, so don't make the mistake. If you do this correctly, if the GCF is 1, and you factor using a formula, then this cannot be factored further. Okay? All right, so here's your answer. Okay, now let's suppose in this example, we're going to do this same example again, because I just want to show you something. Let's suppose that, I'll put this as 3 star. So let's suppose I want to factor 8m cubed plus 64. 8m cubed plus 64. And let's suppose that I did not find the GCF. Now remember, when we did number 2, if you forgot to find the GCF, remember there's nothing cubed, no whole number cubed, that's 5, and no whole number cubed, that's 40. Okay, so and you wouldn't say prime because I can factor this. So obviously you see it can be factored. All right, so that's where you're gonna make sure you gotta use your GCF. But here, if I go directly to writing this as something cubed plus something cubed, it works. I mean, I can fill something in here. It's 2m, because 2m times itself 3 times, it's 8m cubed. And the same thing here, because 4 times 4 times 4 is 64. Okay? So this is your F, and this is your L. Now the end, you're going to notice something that we're going to have to do. So you see, if you don't use your GCF at the beginning, you're going to have to fix it at the end. You will have to fix it at the end. Okay, so it's always a good idea. It's always a good idea to take care of the GCF at the beginning. All right, so notice what's going to happen. So remember, it's F plus L times F squared minus FL plus L squared. Okay, so it's 2m, so F plus L. So it's going to be 2m plus 4. So that's your F plus L, 2m plus 4, times, all right, now this says I take F and I multiply by itself twice. So I take 2m and I multiply by itself, and I get 4m squared. So 4m squared. I'm going to need some more room here, so I'm going to just go down here. So it'll be 2m plus 4 times 4m squared. Now, minus, this says I'm going to multiply F and L together. So that means 2m and 4. So 2m times 4 is 8m. So that goes here, 8m. And then this says I'm going to take L, I'm going to square it. So that's L is 4, so that means 4 times 4, which is 16. So that's plus 16. All right, now that is not your answer, okay? Because if you look at this binomial right here, what else can you do to it? Well, you can factor out a 2. So you got to do that. You got to make sure that you factor it completely. All right, so here I can take out a 2, so that's 2 times m plus 2. And this trinomial, I can factor. Now you're going to say, well, you just said that this trinomial, when you use a formula, you can't factor it. Yeah, that's true if the GCF is 1, remember? If the GCF is 1. But here, technically, if you look at it carefully, the GCF is not 1, the GCF is 8. So if you look at this right here, 4m squared minus 8m plus 4, I can factor out the GCF of that trinomial here is 4. So that's going to be times, remember that's multiplication, so you're multiplying these two things, you got to say times 4 times, and then that's going to be m squared minus 4 times 2m, 4 times 2m is 8m, and then plus 4 times 4 is 16. And so now you take these two monomials and you multiply them together. So you got to multiply them because that's the way we want it. That's the way mathematically you want it written. You want to take those monomials and multiply them. So that's 8 times m plus 2 times m squared minus 2m plus 4, which is the answer we had gotten right here. Okay, so number 3 right here. All right. So notice though, it is a lot easier for you. It is a lot easier for you to have, if there's a GCF other than 1, to have factor out the GCF. It makes things a lot easier for you, because if you had not, a lot of you would have stopped here and you would not have gotten full credit. This is not correct. Okay? All right. So that was number 3. All right, let's look at this example. Suppose we had, let's see, okay, so suppose we had, I'm trying to find one, okay, let's just do this one. Suppose we had 125 plus r cubed, number 4. 125 plus r cubed. Suppose we had that. Okay, so again, the GCF is 1. So we see this is the sum of 2 cubes. And so 5 times itself 3 times is 125. R times itself 3 times is r cubed. So there's your F, there's your L, and then the rest is just straightforward. So there's your F, there's your L. So it'll be F plus L, so 5 plus R, times, and remember this is F plus L times F squared minus FL plus L squared. So so this says I take F and I square it. So I take 5 and I multiply by itself, so that's 25, minus, this says I take F and L, so 5 and R, and I multiply them together, so that's 5R. And this says I take L, which is R, and I multiply by itself, and so I get R squared. And so that's your answer. So that was that one. All right, let's look at this one. Let's see. All right, suppose you had this example. Suppose you had number 5. Suppose we had x cubed b cubed plus c to the 9th. X cubed b cubed. Oh, that's a cubed rather. Sorry, that's cubed. X cubed b cubed plus c to the 9th. All right. So the GCF is 1 again. So we go directly and seeing if this is the sum of 2 cubes. So the first parentheses, that's going to be xb, because xb times xb times xb is x cubed b cubed. Notice xb times xb times xb. X times x times x is x cubed. B times b times b is b cubed. Okay, so I get that. All right, over here, remember our review that we did earlier. If I have c to the 7th cubed, then remember your power rule. So when you have a power, it's a power, you multiply these exponents. So it'll be c to the 21st. So let's think about c to what power cubed will give us c to 9th. Well, the answer is 3, because 3 times 3 is 9. Okay, so c cubed times itself 3 times. Always check yourself. C cubed times itself 3 times. Remember, you multiply like bases, you add exponents, so I do get c to the 9th. All right, so there's your F, and there's your L. Okay, so remember our factorization, our formula is F plus L times F squared minus FL plus L squared. So F plus L, so that's XB plus C cubed times I'm hoping I have enough room here. Times, all right, this says I take f, which is xb, and I multiply it by itself. So I get xb times xb. So that's x squared b squared. So I get x squared b squared. So that's the first term of the trinomial. Minus, all right, so this says I take f, which is xb, and I multiply by l, which is c cubed, and so I get xbc cubed. So xbc cubed. And then finally, this says I take L and I square it. So I take L, which is C cubed, and I multiply by itself. And so C cubed times C cubed, remember you multiply like bases, you add exponents. So that's C to the 6th, C to the 6th power. And so there's your answer right here. You're done. All right, looks complicated, but it really is not that bad. And let's see. I think that's gonna be. Actually, let's look at this one. So let's look at this example. Let's do one more. All right. So number 6. We have 100 x cubed y plus 49. Well, that's not gonna be the difference. That's not gonna be the sum of 2 cubes. Sorry. Let me see if I can find one. Oh, let's see. All right, let's look at this. So let's suppose we had 24. Let's do this one. 24 x cubed plus 81 y cubed. So 24x cubed plus 81 y cubed. All right, so the GCF here is 3. GCF is 3. So let's factor out of 3. So I get 3 times, and that's going to be 8x cubed plus, and then that's going to be 27y cubed, because 3 times 27 is 81. So let's go off to the side, and let's factor this part here. So 8x cubed plus 27y cubed. All right, now notice here the GCF now for this one is 1. Okay, so I'm going to go ahead and see if this is the sum of 2 cubes. So what times itself 3 times is 8x cubed. Well, it's 2x, because 2x times 2x times 2x is 8x cubed. For this one, that's going to be 3y, because 3y times 3y times 3y is 27y cubed. So there's your F, there's your L. So I'm going to get the binomial to be 2x plus 3y, 2x plus 3y. And then the trinomial, okay, so remember, your trinomial is f squared plus, minus FL plus L squared. So F here, right here. So F squared, so that says I take F, which is 2x, and multiply by itself. So 2x times 2x is 4x squared. So that goes here. 4x squared minus, so minus. This says I take F and I take L and I multiply them together. So F is 2x, L is 3y. When I multiply them, I get 6xy. So that goes here. And then this says I take L and I square it. So I take L and multiply by itself. So L is 3y. So 3y times 3y is 9y squared. So that goes here, plus 9y squared. And then remember, this right here, this binomial times this trinomial is the factorization for this. But remember, this was our problem right here. So we had taken out a GCF of 3, so we got to put 3 in our answer. So I'm going to get 3 times, and then remember this right here. This right here is this. So it's 3 times 2x plus 3y times 4x squared minus 6xy plus 9y squared. And so there's your answer. All right, so that's going to be the end of this video.